Hello everyone, this is Zahra Karimi and I will be explaining Postfix Expression Evaluation using stack. What is a stack? Stack is a data structure and it is used to store data in a particular order. Push and pop are the two important operations inside stack. Push operation basically is used for inserting data inside stack, and pop operation is used to remove the topest element inside the stack. One of the most important things that we have to know about stack is that it follows the principle of LIFO, last in, first out. Means that the very last data which is inserted inside stack is the very first data which will be removed. So stack has many implementations, and one of the implementations is that it is used for writing or for evaluating different ways of writing. For example, we have infix, postfix, and prefix, which are different notations writing or which are different writing arithmetic expressions. So basically my topic is I'm focusing more on evaluation of postfix expression, which is my main topic. So what is postfix expression? So postfix notation is a way of writing arithmetic expressions, and it follows the scheme of operand operator. So postfix expressions do not have parentheses, unlike infix expressions, and they follow the principle of operand. Means that two numbers come before the operator. Operands means the numbers which are used for calculations. In postfix expressions, operands appear before their operators, and there is no need for any parentheses, and due to this simplicity, some handheld calculators, they use postfix notations in order to avoid the complications which is caused by the parentheses in infix expressions. So the algorithm is pretty easy. First of all, we will declare a stack to store the postfix expression, operands and operators. So this stack is going to be an array. So we are using static memory allocation, which means that we are implementing stack using arrays. After we have created the stack or the array for storing the postfix expression, we are going to traverse through the characters in this array. So we will read them one by one and scan each element. If the element which is inserted is a number character, then we will push it inside the stack. If the element which is inserted by the user is an operator character, for example plus, minus, asterisk, or slash or power, then two topest elements will be popped out of the stack and the operation will be performed, and the final result will be pushed back into the stack. And once the checking is finished, the last result or the topest element will be the result of our expression. That easy. In order to use postfix expression graphically, we will take this post expression as an example: 743 star 15 plus slash star. So we're going to traverse through this expression. We check the very first element. The very first element is an operand, which is a number. Then we are going to push it inside the stack. Now the top will increment and the top will become 0. So we will check the second element. The second element is also a number, and then we are going to push it inside the stack. Now the top will increment and it will become 1. The third element is also an operand and it's a number, so we are going to use the operation push and we are going to push it inside the stack. Now the top is incremented by 1 and the top is 2. So the fourth one is interesting. We have an operator here. So what do we do? According to the algorithm, we are going to pop these two topest elements: 4, which is index 1, and 3, which is index 2. 4 will become the very first number for calculation, and 3 will become the second number. The result of the operation will be stored back inside the stack. So in here, if we multiply 4 by 3, so the result will be 12, and 12 will be added inside the stack. And now, as you can see, the top is decremented from 2 to 1. The fifth element is also a number. We will use the push operation and we will push it inside the stack. And now the top is incremented and it will become 2. The sixth element is also an operand, which is a number. we are going to push it inside the stack, and now the top is incremented by 1, and now the top is 3. The 7th element is an operator, a plus operator. So according to the algorithm, we're going to pop out the 2 toppest element. 1 will be the very first number for calculation, and 5 will be the second operand, and then the result will be pushed back inside the stack. As you can see, the top is decremented. The 8th element is also an operator. As usual, 2 toppest values will be popped out. 12 will become the very first number and 6 the second number. And if we divide 12 by 6, the result is 2. 2 will be pushed back inside the stack, and now top is decremented into 1. The 9th element is also an operator, which is the multiplication. So according to the algorithm, we're going to pop out the 2 toppest elements. In here we are left with 2 elements. So the result, which is 14, it will be pushed back inside the stack. The toppest element in here, which is 14, will be the final answer. What is time and space complexity? We have many algorithms for a problem, and the best way to choose among those algorithms, the best one is to evaluate the time and space complexity. It measures the performance of each algorithm. So the time complexity is the number of operations an algorithm needs to perform in order to complete its task by taking into account the input size. Based on this definition, our algorithm will take n numbers of characters. It depends on the input which is inserted by the user. So basically the time complexity for this algorithm is going to be big O n, and n refers to the number of characters for which the loop will be executed to scan each of them. Remember, we have to go through each element and we have to check condition one by one for them. Space complexity of an algorithm is the total space it takes with respect to the input size, or the amount of memory which is used by the algorithms to execute and produce the result. So based on this definition, we can say that space complexity for my algorithm, or for this algorithm, is going to be big O n, because n refers to the characters that take space in the memory. If we have many characters inside our array or inside our postfix expression, so as the number of these characters increase, the amount of space that those characters will take inside this and the memory will increase too. So this is my code. We will include the 2 libraries, IOStream and math. I use this library for power operation using namespace std. So I have declared some global variables, a stack of a maximum size 100, I for iteration purposes, size for the size of stack, and top, and I have initialized this to -1. So I have operations. Okay, main operations include push, pop, and main. So in push operation, we are going to insert elements inside the stack, and before doing that we have to check some certain conditions. If the stack is full, we cannot insert elements. So in that case, the stack will this message, the stack is overflow, will be displayed. So I have used exit -1 in order to terminate the program if this condition is met, in order for some other print functions or print statements that I have inside my main for them to not be displayed. So that's why I'm using exit -1. And else, if our stack is empty, then go ahead and add the items. So in the second function we have pop function. Pop function is used for popping out the elements and storing them in variable. Unlike other pop functions in stack, we have a return type which is integer. We are not going to remove the values. We are going to store them for further operations. So we will check some conditions. If the top is -1, then the stack is under flow, which means that our stack is empty, and terminate the program. Or else, take the toppest element, store it inside n, and decrement the top, and then return the n. So here is our main function, which contains the algorithm. At the starting of main function, we are going to ask the user to input their stack size, and we are going to store that value inside size. and we are going to declare an array of postfix which is of type char. We will need some other variables too, such as a, b, result, p, evaluation, and a variable of ch of type char. Sorry. So I will explain in the following lines of code why do we need this though. So after the users have inserted the size of this tag, we will ask them to insert the postfix expression, and then we are going to store that inside postfix. So now the for loop starts, traversing through each element of the given expression, and this loop executes until the element inside the postfix will become null. Yes. So the iteration, it starts from 0 and it goes until this condition is met, which means that it continues until the postfix element is not a null element. The char ch that I have declared here, this will take the elements which are inside the expression. If this element is between 0 and 9, or these characters are 0 to 9, then push these characters inside the stack. Remember, in here the char, we have to change the char in number in order to calculate them for further arithmetic calculations. So since characters inside C++ programming are written in ASCII value, so the ASCII value for 0 will be 48, and ch minus 48 means that the ASCII values of the characters are subtracted from each other, since 0 comes directly before 1 in the ASCII table, and so on until 9. If we subtract 48 from the numbers, so it will actually give the number of that character. Else if, check if they are operators. If the characters of one if the characters are one of these operators, then do the following statements. Pop the toppest element, pop the second top element, and store them inside B and A. And then we will go to the switch cases. If the operator is plus, then we will perform the addition. If the operand is minus, then we will perform the subtraction, and we will go on. When these conditions are met, the final results will be pushed and stored inside the variable result, which we declared at the beginning. And as the final answer, in order to display that for the user as the number which was evaluated, we are going to store the number, or we were going to pop out that element, and we will store that inside P evaluation. And we will have a message for the user that the postfix evaluation is this number. So now let's run the code. Okay, I'm gonna use the one that I used for the example. 14 7 4 3 1 5 plus, the output is 14. And this was all about my code. Thank you.